So here I am starting the video once again. Yes, it is visible. Let us switch to full screen mode. Yes. So the kit of band gap setup, I hope, is visible to everyone. Is it? Please respond in the chat box. Yes. So what do you mean by band gap? Do you know? Band gap is the gap between the valence band and conduction band of any material. Okay, like here we are going to determine the energy band gap for a semiconductor diode. So we are going to determine the gap between the two bands, the last band containing the valence electron and the imaginary band after which in which the electrons are going to jump if we provide some sort of energy, and then the electrons are going to conduct. Yes, it is forbidden energy band gap, right? So that energy band gap we are going to determine with the help of this experiment. Okay, now this experiment we are going to determine the band gap of diode. So the first component of our experiment is a PN junction diode. So if you look at this is our PN junction diode. The symbol of the diode, the triangle indicates P and the line indicates N. Now there are two ways of biasing this diode, either forward bias or reverse bias. In this experiment we are going to reverse bias the diode. Okay, because in reverse bias the current is very small, which is in microampere, which we called it as minority current. Okay, and this current basically depends upon temperature. For changes in temperature the current also shows changes. Only which current? Reverse bias current, which is a minority current. Okay, so what we are going to do is we are going to keep this reverse biased PN junction diode inside a furnace. So this furnace will heat the diode. Okay, so there is a direct relationship between the energy band gap of the diode, e.g. the current, minority current flowing through it, and the temperature T. So knowing any two values we can determine the third one. Okay, so this is the concept. There is, these three things are related to each other. There is a relation between the energy gap, the current, which is basically the minority current, which is obtained in reverse bias, and the temperature applied to the diode. So using the relation, common relation among these three, if we know two parameters we can always get the third one, right? So in your record you will have one formula at the beginning, that Eg equal to minus of slope upon 5.036. So 5.036 is a constant number. You are supposed to get slope. Okay, how to get the slope? It's the simple, from any graph where the value of slope is generally taken as y2 minus y1 upon x2 minus x1, etc. Okay, so for this experiment we are going to have a graph from which we are going to get the slope. If we put the value of slope here, we will get the value of Eg in electron volts, right? Now just pay attention. What you are going to do in the experiment is, now I will tell you about the apparatus. So of course one apparatus you have got to know that it consists of a diode. The diode is kept inside a furnace. So this is a furnace. This furnace is going to heat the diode. Okay, so there is a supply of current to the furnace. Furnace is nothing but a coil which is going to get heated with the help of some current supply through it. So this is for the supply of furnace, oven. You can call it as oven. So here it is written oven supply. Okay, so this part is for supplying current to the oven so that the oven will get heated. Then the diode inside is kept in reverse bias mode. So this part of the circuit is for making the diode in reverse bias mode. So this is voltage which is supplied for the diode to make it reverse bias. Okay, so there are two plugs, or we can say the buttons. One button will operate the oven and one button will operate the reverse bias diode, right everyone? Okay, then there is a digital panel in this kit. The digital panel will display the value of voltage, current and temperature all together. So this is a modern kit, very new kit. That's why it is having this facility of having all the three displays together. Earlier where we had the older kits in which we had some windows, analog windows, through which we can see the voltage, current, and the thermometer was like the normal thermometer having methyl alcohol or mercury, which will display the temperature readings. So this was older kit. The concept is same. This is new kit having digital panel. Okay, so we'll do the experiment in digital panel so that only in one screen you can see the readings of current and temperature together. Right everyone? So I hope you have understood the apparatus of the experiment. The diode, which is in reverse bias mode, then the furnace or oven, which is going to heat the diode, and the temperature meter, maybe digital temperature meter or maybe kind of thermometer. Is it clear? The apparatus समझ में आया सबको? Keep on replying me in the chat box so that I can understand that you are listening to my words. Yes. Okay. Now I will tell you the procedure, how to do the experiment. Okay, it's very simple. What we are going to have is, we want the readings of current and temperature. Okay, so you must be having an observation table with you from your record. Have you drawn the observation table? Just check out the observation table everyone. That in your observation table you have serial number of the observation, then temperature readings in degree Celsius, then you can have temperature readings in degree Kelvin, then you can have noting of current, then 10 to the power 3 by T for this Kelvin temperature, and then log of I. Okay, so what we are going to have is, we are going to have the readings of temperature and current together, right? So we are going to first raise the temperature of this oven. We will raise the temperature of this oven to some 70 degrees Celsius. Then we will turn off the oven, and then we will record the readings of falling temperature and falling current. With temperature raising, the current also starts raising. Okay, but we will not take the readings while raising the temperature, because heating process is not uniform process. It is followed by the conduction, convection, radiation, etc. But cooling process is uniform process, right? So we will record the readings while cooling the temperature. Okay, so क्या करना है आपको? You are supposed to only record the readings of temperature and current, temperature versus current. Temperature you will raise up to some 70 degrees Celsius or 75, whatever. Then you turn off the oven. Then the temperature will start falling in the reverse order, like 70, then 65, then 60, and so on. So this you can keep writing. Okay, this column you can make a field right now, because this is your reference column. With respect to this, you are supposed to record current. Okay, so you can make this column right now, complete this column: 70, 65, 60, 55, 50, 45, up to maybe 40. Okay, you can take up the readings up to 40. Okay, then the current readings we are going to determine when we will start performing the experiment. So what we are supposed to do is, I will turn on the plug, I will turn on the supply to the oven, and also I will turn on the supply of diode. Okay, now I will show you the screen, if you are able to see the screen. And the screen is getting complete brightened. Yes, the screen, because it is a digital panel, so this camera is not recognizing the words which are displayed on the screen. Let me try to adjust this little bit, so that in any form I can get. Okay, it's too bright. Yeah, I know. Okay, is it visible now? Are you able to see the screen now? Yes. So it is showing voltage reading, it is showing temperature, and it is showing current. Yes. So voltage is right now some 6.35 etc. You can supply the voltage maybe 6, maybe 10. You can change the value of voltage using that voltage knob. Okay, so suppose I will supply it to some 6 volts. Yes, can you see the voltage? I am trying to adjust it to 6 volts something. Yes, 6.05 means 6 volts. Okay. Then can you see the temperature? How much is the temperature right now?
71.
Yes, 71 is the temperature. And can you see the current also?
Yes, ma'am. 249.28 microampere.
Yes, very good. So now this is temperature and current readings. Now once it will become 75, we will turn off the oven. Okay. Then I will just hold the camera like this and you will start recording the readings of temperature versus current. Temperature table, have you made it completely? You are just supposed to make it reverse from 75 to 40 at difference of 5 degrees. Have you done it, everyone?
Yes, ma'am.
Okay. So now once it will become 75, we will start recording the readings. All of you will simultaneously write down the values of current for the corresponding temperatures. Yes, now it is going to be 75. Okay, let it be 75 up to some while. After 5 or 10 seconds we will turn off. Yes, now it is going to be 76, so I am turning off the oven. So here oven goes off. Now just, yes, 75. How much is the current? 249.28. Right? Start recording. Now it is falling fast. 72, 71. I will record for 70. Yes, 70. It is 240 point something. Now it is falling very very fast. 70 के लिए 240 रिकॉर्ड कर लो. Now we are interested in 65. Yes, 65, 128. It is falling faster, so we are taking only one reading in between. जब हमने उसको मैक्सिमम टाइम देख लिया था. ठीक है.
Ma'am, what is the current at 65?
It was 128 something. Now let us wait for 60. So it is 79. Then now 55. We are going to wait for. Is the screen visible to everyone?
Yes, ma'am. It is bit visible, but not clearly.
But can you record the readings at least?
Yes, ma'am.
Okay. Now for higher temperatures it will fall very fast, but for lower temperatures it will take time to fall back up to the normal. Okay. Yes, now it is going to be 56, but we wanted 55, so let it be 55. As soon as it became 55, we will record the reading, whatever it may be. Yes, 55, let it be 55. So it is 55 current itself.
Ma'am, can you please repeat voltage at 55 temperature?
No voltage, it is current. 55
Yes,
current, 55 microamps. Yes, now we are moving towards 50. Yes, how many readings we have recorded till now?
8 readings, ma'am.
8 readings. 4 readings, huh? We have taken 4 readings till now. It was 75, 70, 65, 60 and 55. Yes, 5 readings. It should be 5 readings. Now the 6th one is for 50 degrees Celsius. it has become now 52. It is becoming 51 now, but we are waiting for 50, and then it will take a while to reach 45. So till the time I will explain you how to do the further calculations till it becomes 45. Okay. Because the meter is digital, so it will fluctuate a little bit between 51 and 52. Once it will reach the value exact 51, it will stop fluctuating. This is the drawback of digital meters. In analog meter, like the simple thermometer, you can see only one reading at a time, but digitals may have fluctuations unless and until you get the constant input. Yes, now it is becoming 50. Let it become proper 50, then we'll record the reading. Yes, so 50, it is 40. Okay, for 50 it is 40 microamps. Now I will explain you further how to do the calculations till the temperature falls to 45. It will take some maybe 5 minutes. Okay, so now what you are supposed to do is, you have readings of temperature in degree Celsius, and then let me adjust the clarity. Yes, and then you have the readings of current in microamps. Okay, you don't have to write the 10 to the power minus 6 factor, etc. It is only written on the top, it is in microamps. Okay, now what you will do is, you will convert the temperature of degree Celsius into degree Kelvin. How will you convert the temperature of degree Celsius to degree Kelvin? What is the method? Anyone?
Addition of 273 Kelvin.
Yes, we will add 273 to the values of degree Celsius. Okay, 273 will be added to value of degree Celsius, so it will become degree Kelvin. Okay, then you are supposed to do 10 to the power 3 by T. Okay, 10 to the power 3 means 1000. You are supposed to divide it by the value of temperature, which is in Kelvin. Okay, so like 10 to the power 3 means 1000 divided by first one, it may be suppose 300 and something, second one 300 and little bit less, likewise. So temperature readings are going to get reduced, so 10 to the power 3 by T readings are going to get increased because it is 1 upon T, right? And then next, last is log of I. So you will be doing log of I, means this I, which is in microampere. No need to consider microampere. Whatever the number is there, you have to generally directly do log with the base 10 of that number. Understood everyone? Like first was supposed 243, so log of 243, log of 230, log of 100 and something, log of 10, etc. like this. Okay, so in this way you will complete the table first. Then you are supposed to plot a graph of 10 to the power 3 by T on x-axis and log of I, this was log with the base 10 of I on y-axis. Okay, you should use connector because your graph readings will all get concentrated between very close regions. Like your complete readings of 10 to the power 3 by T will come maybe from 1 to some 1.2, etc. So you will elaborate this region properly, and while elaborating this, after 0 we are taking directly some bigger number. There will not be a constant difference from 0 to this and then this point to this point, so we will show a connector there. Okay, similarly for the scale of y-axis also, your complete readings may get concentrated suppose from 2.5 to 3, so that 2.5 to 3 region you will show broadly, and again you will show a connector in the beginning. Okay, this means you have shifted the scale directly to the reading points. Okay, so 0 to that point is not having a constant distance, we are having a connector there. Okay, so suppose my readings are coming like this, this is 1 point, this is second point, this third point. So I will draw the line passing through optimistically between the points, such that some points above, some points below the line. On my line no point is falling, that's okay for me because I am considering the positive error and negative error balanced. Understood everyone? So this is the method to draw the graph each and every time, that your line should pass optimistically between the points, considering the positive error, negative error balanced. You should not only consider the downward points, you should not only consider the upward points, you should consider the complete set of points to pass the line. Is it clear everyone? And then you select any 2 points from your line which are not your readings, any 2 points which are crossing the graph paper properly at the corners. You select those 2 points which are not your reading points, and then draw a triangle there, we call it slope. Then do the slope calculation on the graph paper itself. Slope is calculated how? Just simple, y2 minus y1 upon x2 minus x1. Now since the line is reverse, because it is the graph between 1 upon this t, 10 to the power 3 by t means t is taken reverse, and log of I, the graph will come reverse. Okay, and hence slope of the graph will come in negative something. Okay, are you getting this point? The slope will come in some negative value, and then this slope you are going to put in the formula which is given at the starting, minus slope upon 5.036. So minus of minus, it will come plus some number. So this number will come plus 0. Some x, like 0.2, 0.3, 0.4, 0.11, 0.22, whatever. Okay, 0. Some number will come. Okay, slope upon 5.036, this is minus of slope upon 5.036. it is already minus and your slope is going to come in negative, so minus and minus it will be plus, because energy cannot be negative, it will be always positive number. Right everyone? Now how much this value of energy should come? So band gap is generally having a range decided as per the material. Like for silicon, the band gap will be always in a range of 0.7. For germanium, the band gap will be always in a range of 0.3 or something. Okay, so looking at your band gap value, you can tell whether your diode was a germanium diode or a silicon diode. Is it clear everyone? समझ में आ गया है सबको एक्सपेरिमेंट क्या करना है? Now let us check, has it reached to 45? No, it has not yet reached to 45. Yes, it is up to 48 till now. Let us wait for 2 minutes more. Till the time you tell me, have you understood what we are supposed to do next? Please type it in the chat box. Okay, please do not unmute yourself. You can always type it in the chat box, whatever you want to say. Yes, so after that you have to first complete the table. Okay, you are supposed to complete the table. You want me to explain the graph once again? I will explain you once again. You will have to draw a graph having 10 to the power 3 by t on x-axis and log of I on y-axis. These value you are going to get from the table. Okay, last 2 columns of the table are these one. Okay, and then yes, how to make the graph? The values of your 10 to the power 3 by t and the log of I, that will decide the scale. Okay, suppose your values are like 1.1, 1.12, 1.13, 1.2, 1.21. So all the values are concentrated from 1 to suppose 2.5. So only that small range of 1 to 2.5 you have to elaborate properly on the complete scale. So we have shown here connector. Okay, I will not take the scale like 1, 2, 3, 4. If I take the scale 1, 2, 3, 4, my whole graph will get concentrated in this small area. I will elaborate this small area, like we zoom in the pictures in the mobile phone. So same thing I am going to zoom out this graph. So ये 1 से लेके 2.5 तक का region I will elaborate. Okay, like I will elaborate it 1.05, 1.1, 1.15, 1.2, 1.25, 1.3 like this, so that my all points will come at spacious from the graph paper. Okay, the complete graph paper will be utilized properly. Same will be the case for log of I. ये वाले रीडिंग्स भी आपके बहुत कम एरिया में कॉन्सेंट्रेट हो जाएंगे, तो आपको वही एरिया पूरा बड़ा खींच के इलेबरेट करके ड्रॉ करना है. समझ में आया सबको स्केल कैसे लेना है? देन यू विल प्लॉट द पॉइंट्स, यू विल पास द लाइन ऑप्टिमिस्टिकली. जैसे 1 पॉइंट नीचे तो 1 पॉइंट ऊपर, 1 पॉइंट नीचे 1 पॉइंट ऊपर, इस तरह से 3-4 पॉइंट नीचे 3-4 पॉइंट ऊपर करके लाइन आनी चाहिए. आपके पॉइंट्स अगर लाइन पे आ रहे हैं तो बहुत अच्छी बात है, नहीं आ रहे तो इस तरह से पॉजिटिव निगेटिव एरर बैलेंस करके आपको लाइन ड्रॉ करना है. इज इट क्लियर एवरीवन? that's called optimistic graph. And then select any 2 points on the graph which are properly crossing the graph paper. Okay, so these should not be your reading. ये आपके रीडिंग नहीं होने चाहिए. ये ग्राफ के ऊपर के जो प्रॉपरली ग्राफ पेपर के बॉक्सेस को क्रॉस कर रहे हैं ऐसे पॉइंट्स होने चाहिए, और फिर उन पॉइंट्स को सिलेक्ट करके वहाँ पे स्लोप निकालो. दैट्स इट. और ग्राफ के ऊपर ही ईजी का वैल्यू निकाल के दिखाओ. टुडे यू विल बी शोइंग मी द वैल्यू ऑफ ईजी ऑन द ग्राफ पेपर इटसेल्फ. सो यू विल बी पोस्टिंग द फोटोग्राफ्स ऑफ योर ग्राफ ओनली, राइट? ओके, इट हैज़ बिकम 45 एंड द रीडिंग इज 29. लेट इट बी 45 प्रॉपरली होने दो. यस 40, येट टू बी 45. यस 45. ओके, नो नॉट इट. बिल्कुल 46 हो रहा है बीच बीच में. तो समझ में आया सबको ग्राफ कैसे निकालना है? Yes, so now it is okay. So now 45 and the reading is 28. Last reading 45 के लिए 28. अभी भी हालांकि नहीं हुआ है exactly 45, but it will be 45 के लिए 28 रिकॉर्ड कर दो. I will turn off the apparatus now. Turn off from the panel and then turn off from the supply. Right everyone? So what I expect is everyone will complete out this table. Okay? सबको ये टेबल कंप्लीट करना है पहले, कैलकुलेशन वाला. टेम्परेचर इन डिग्री केल्विन, देन 10⁻³ then log, and then you will draw the graph on the graph paper using proper scale etc. Write down the name of the graph, that is band gap experiment, then write down the scale etc. and then do the calculation of slope and EG on the graph paper itself properly. Okay, will you be doing it now? Yes. So here I stop my video.